In this short tutorial, I'll share with you how to calculate empirical formulae. So the first thing that we need to do is identify an empirical formula. An empirical formula is a simplified version of another formula. So for example, if you simplify glucose, C6H12O6, you get the empirical formula, which is CH2O. C6H12O6 is the molecular. Once you've calculated the empirical formula, you can use this to calculate the molecular formula, which we'll do in another lesson. So the way that a problem like this might work is that you would be provided with the elements that are contained within that compound. And then for each of the elements, you would be given a particular mass. So how much carbon is there, how much hydrogen is there, and how much oxygen is there. So then by working through the process, you would find the ratio of these three elements together in that compound. So you would find out how much carbon there is, how much hydrogen, and how much oxygen there is in the empirical formula. So let's give it a try. Here's how to calculate empirical formulae. So there's a little poem that might help you in terms of the steps that you'll take. So if you're given a percentage, convert it to a mass. If you're given a mass, convert it to moles. Then in both cases, divide by the smallest and then multiply until whole. Let's see how this looks in practice. So let's say that you start with 1.4 grams of nitrogen and 0.3 grams of hydrogen. The first thing that you want to do is to convert this into moles. In order to do this, we're going to take the mass and divide it by the relative atomic mass. So we'll take 1.4 grams of nitrogen and divide it by 14.01. Now right here, I am writing out all of my decimal places because I don't want to round until the final answer. So then I'll do the same thing for hydrogen, 0.3 grams, and we'll divide this by the relative atomic mass for hydrogen, which is 1.01. And once again, I'm going to take a note of my complete answer, how many moles I have, because I don't want to round until the final answer. Now I'm going to look at how many moles I have for each element, and we'll identify which one is the smallest. So in this case, the number of moles for nitrogen is smallest. So what we do once we calculate moles is divide by the smallest. So for nitrogen, that would be taking the 0.9992862 and divide it by itself because it's the smallest number. So obviously that's going to give us 1. For the hydrogen, we're also going to divide by the smallest. So we'll take the 0.2970297 and divide by the smallest, but in that case, that's the number of moles that we had for the nitrogen, which is 0.09992862. When we do this division, so in both cases, we're dividing by the smallest number. For hydrogen, we get approximately 3. So therefore, our ratio is 1 nitrogen to 3 hydrogens. So from this, we can derive an empirical formula that would be N1H3. In its most simplified form, it's just simply NH3. So now we'll look at a second example. In this case, you're being given the percentages of each element. But it's actually not that complicated because if you assume it's a percentage out of 100, then you can just convert it directly into grams. So we have 32.8 grams of chromium and 67.2 grams of chlorine, and we're going to follow the same steps. So the first step is to convert the mass to moles, and in order to do that, we're going to take the mass and divide it by the relative atomic mass. So we take 32.8 and divide it by 52 to give us the number of moles of chromium. Once again, I'm writing out my numbers just because I don't want to round until the final answer. For chlorine, we'll take our 67.2 grams of chlorine, divide it by the relative atomic mass of chlorine, 35.45, and that will calculate for us the number of moles of chlorine that we have. So just as per our first example, we need to identify for which one we have the smallest number of moles. So that would be for the chromium. In which case we're now going to divide by the smallest. So for the chromium, that's 0.63076923 divided by itself, because it is the smallest number of moles. So this obviously would be 1. If we do the same thing for chlorine, so we're always dividing by the smallest number of moles in any case. So we take the 1.89562764, but we're going to divide it by the 0.63076923, which was the smallest number of moles. And when we do this, we in effect get 3. So therefore our ratio is 1 chromium to 3 chlorines. So that gives us an empirical formula of CrCl3. Now this is fine as long as your ratio essentially comes out to whole numbers, but if the ratio that you calculated of the elements is, for example, 1 to say 1.5, then you're going to need to multiply until whole. So in this case, when you have 1 to 1.5, to get a whole number, you would need to multiply both of those by 2. So if we multiply them by 2, the ratio becomes 2 of the aluminum to 3 of the oxygen. And therefore our formula would be Al2O3. So this is all well and good because multiplying both of them by 2 is pretty straightforward. But then probably the most difficult one you need to identify is if you get a ratio where you have 1 to say 1.3 reoccurring or 2.3 reoccurring. In other words, kind of a third. So if you're going to multiply this until whole, instead of multiplying it by 2, the most convenient thing to do here is multiply both of them by 3. And if you do that, you are going to get a whole number, and in this case it would be C3H4. So just be aware of the ratios that you get. Now the best thing that you can do is, having taken notes on this tutorial, is go away and practice this. Practice multiple questions until you're comfortable with the process.